a tube with optical glass fibers and lenses inside attached to a video camera. Doctors feed the endoscope through the patient's mouth or other opening, or insert it through a tiny incision. Then watch what the camera captures on a video monitor. An endoscope lets the surgeon see inside the patient during an examination or surgical procedure. Its light-transmitting optical fibers work like a flashlight inside the body. The optical fiber manufacturer suspends glass rods from the top of a tall oven, which heats them to a melting temperature of 1652 degrees Fahrenheit. Each rod drips downward in the form of a thin strand. A guide wheel turns this glass fiber in a horizontal direction. The fiber then winds onto a drum, whose rotation speed stretches it to a specific hair-thin diameter. A worker combines several single fiber spools onto a large winding wheel to make a bundle containing thousands of fibers. To make the cable that connects a light source in the operating room to the endoscope, a worker inserts an optical fiber bundle into a silicone cable sheathing. This one has nearly 9,000 fibers. She screws a stainless steel fastener called a ferrule onto each threaded end of the sheathing. After saturating the ferrules and optical fibers inside with glue and curing the adhesive with heat, the worker trims off excess fibers and hands off the cable to the next station, where a worker polishes both ends. Polishing finalizes the dimensions and enables light to shine through. This quality control test, one of several, ensures the fibers can withstand a prescribed amount of pressure without cracking. The optical fiber manufacturer also supplies fiber spools to the endoscope manufacturer for the light transmission system inside the endoscope. Workers cut the bundle of optical fibers to the length required for the endoscope model they're making. Endoscopes vary in length and diameter, depending on the part of the body they're designed for. After verifying that the diameter of the bundle is correct, they tie the optical fibers with string to hold them together during insertion. Then, workers insert the fiber bundle between the inner and outer stainless steel sheaths that make up the main body of the endoscope, pushing the fibers down the length of the inner sheath. They attach a stainless steel adapter. This will connect the light cable from the operating room light source to the endoscope, transferring light to the optical fibers inside the endoscope. A worker inspects those fibers under magnification for black spots. Black spots indicate broken fibers, which would interrupt the transmission of light. An endoscope transmits an image much like a telescope does. Optical lenses send reflected light which produces the image from inside the patient all the way up to your eye peering through the top. The lenses in the endoscope are glass rods. After cleaning them with a chemical solution, workers line them up in a fixture with brass spacers of various lengths in between. Depending on the length of the endoscope, there are 5 to 7 lenses. The spacers create specific distances between them. Once workers have assembled the image transmission system, they gently slide it off the fixture into the inner sheath of the endoscope. Then they screw on an ocular cap to hold it all in place. A worker cleans the cap's glass top, then attaches an eyepiece. This gives the surgeon the option of either looking directly into the endoscope or looking at an operating room video monitor, which receives the image via a small camera attached to the eyepiece. This demonstration shows how it all comes together in the operating room. After securing the endoscope in a holding fixture, the surgeon attaches the light cable coming from the nearby light source. The light travels down and out the endoscope, illuminating the area the surgeon's working on. The lenses reflect the image to the top of the endoscope, where a camera transmits it to a video monitor that's mounted in front of the surgeon.